Hello and welcome to Friday's edition of Cracking the Cryptic. Now on screen you can see we're going to be looking at a little killer Sudoku today. I'll tell you a bit about this puzzle in a moment, but I want to mention for our patrons first of all that this month's Patreon reward video is now up on the site. So anyone who wants to see how to solve the sandwich Sudoku that we set for you at the start of the month, there is now a video where you can watch our solve of it. Now let me tell you about this puzzle. This came in from Mitchell Lee, who introduced himself as a member of the Galactic Puzzle Setters, and that immediately got my attention. Why? Well, the Galactic Puzzle Hunt is a sort of annual online competition that's been happening for the last 2 or 3 years. Unfortunately, it's not happening this year because I think they're off to set the MIT Mystery Hunt, which is an absolute, it's so disappointing because the Galactic Puzzle Hunt is one of the highlights of my year. And the puzzle setters for it are therefore complete puzzle setting geniuses. People like John Schneider, who created, well, still the most difficult puzzle I've ever seen, called Adventure. We did a video about that earlier on in the channel's infancy. It took us a whole video just to explain the question. And we never did get around to explaining the answer in a video, which is remiss of us, and we must do that at some stage. But Mitchell is a member of their team, and I sent this to our tester and said, look, this might be quite good. And the tester's feedback was, oh yes, this is good. So we are in for a treat. Now, how do little killer Sudokus work? Well, they are very simple. You can see we've got some clues outside the grid that point along diagonals. So if we look at the 16 clue, these 6 cells would have to sum up to 16. Now you can repeat digits along this line. Obviously these 2 squares couldn't be the same digit because they are in the same box, but it would be absolutely fine for those 2 to be the same digit, for example. That's completely okay. And rather unusually, we have a does not equal little killer clue here. So this diagonal does not equal 56. You can see the mouse is going crazy. I just want to tell you about the mouse, right? It's not that my mouse is bad. I have a super duper gaming mouse, which I need for all the gaming I do. But the interaction of the mouse with the video editing software is temperamental, and that is why I'm having issues. I don't want to learn a complete new system of video editing software. So I tend to just pause the video and reconnect the mouse, and that seems to fix the problem. So I'm just going to do that quickly. All right, there we go. Now, as usual with Cracking the Cryptic, if you want to have a go, do click on the link under the video. That will take you to this web page where you can play along. And with that, let's see what Mitchell's puzzle has in store for us. Right, we've got a 6 clue here. So those 3 cells have got to be 1, 2, and 3. 22 clue here, so one of these squares has got to be a 9. 23 clue here in 3 cells, we know that's got to be 6, 8, and 9. 12. This 12 clue, look, that's pointing at 6 squares, but in each, 3 lots of the squares are in the same box, so the minimum I can make 3 squares add up to is 6. We've already seen that. So these squares all have to be some combination of 1, 2, and 3. So it's going to be 1, 2, and 3 in this box, 1, 2, and 3 in this box. 12 clue down here doesn't. That's got a few options. 37 clue on the diagonal has got zillions of options. Now the 16 clue. Yes, the 16 clue now. This 16 clue is interesting. And why? Well, that's because, look, in this box, the numbers 1, 2, and 3 have already been taken. So the minimum I can make those 2 squares would be 4 and 5. 4 and 5 add up to 9. We know the minimum I could make those 3 squares would be another 6 if I make them 1, 2, and 3. And that just leaves enough room for this square to be a 1. So we can fill that in. That's our first digit in the grid, a lot earlier than yesterday. And okay, I'm not sure Can't see anything else to do with that immediately. So let's have another look around the grid. Yeah, okay, the 44 clue now. That must be restricted because this square is so low. So ordinarily, if this square hadn't had complete, if we had all the options available for this square, this combination would have quite a lot of license. But once we make this as low as a 3, in fact it has to be a 3, because if it's less than 3, we can't make these remaining 5 cells add up to enough. We can make these 3 squares add up to 24 if we use 7, 8 and 9. 7, 8 and 9, so 24 plus 3 is 27. These 2 squares would have to be maximal as well, so 8 and 9 into those 2 squares. Now this 3 sees that too, so that gives us another digit. Can get rid of 3's in those 2 squares and over there. Oh, now we have a nice thing. Yes, look at this 1, 3 pair. Oh, sorry, no, what, not 1, 3 pair. This should, I've deleted the wrong digit there. I'm glad I spotted that. That would have been a disaster. I was about to write 1 and 3 into those 2 squares. Right, but look, we do have 1's in those squares. So we know where the 1 goes in this box. It must be in column 7 or column 9. We know the 1 in this box is also in column 7 or column 9. So we know column 8 hasn't got a 1 in any of those positions. So the 1 has to be in one of those 3 squares, and we know it can't be here because of the 22 clue. So the 1 is in one of those 2 squares. This, no, see, I must have had my finger on the wrong digit when I was deleting things. So this one, I need to get rid of the 3, not the 2. And what next? Yeah, look at this. This 39 clue. Yes, the 39 clue is interesting because we've sort of got the opposite to what we had up here. Up here, we had a minimum number that we could make these 2 squares. Here, the maximum number I can make those 2 squares is going to be 5 and 6 because the 7, 8 and 9 have already gone. Now, if I make those as large as possible, these 2 squares obviously add up to 11. The maximum I could make this square would be 9. That would give us 20 in this box. I still have to make 19 in this box, but this square can be a maximum of a 2. So it's going to have to be 2 to allow me to place 8 and 9 into those 2 squares. So that's a 2. This has to be a 9. No, oh, there's a 9 in one of these squares at the top. Look, that gets rid of a 9 there. Let's get rid of the 2's. Oh, did it again. Get rid of the 2's in those 2 squares. And let me just have a stare at this to make sure, yeah, this 2 and this 2, they interact on that block. Lock a 2 onto that diagonal with the 37 clue. 1 here is locked into one of those 2 squares. And what? And what? What am I meant to do now? Okay. Now, if we look at the central row, look, we've got 8's and 9's in these squares. So 9 can only go in one of those 2 positions because of the 9 at the bottom. And 8 must be in one of these 3 squares as well. threes. Look at these threes. This pattern keeps coming up. So again, if we look at this box, the 3 is locked into row 1 or row 3. In this box, the 3 is locked into row 1 or row 3. Therefore, we need to think about where we're going to put the 3 in row 2 in this grid. It can't go in any of those squares, so it must be one of those 2 squares. And now the 3's interact again. And lock a 3 into one of these squares. And can we do any better than that? There's so many of these pairs dotted around the grid here. It's a fascinating pattern. Ones. Where can 1 go in the central box? We've got this pattern of 1s in row 4 and row 6. We know the 1 is in one of these 3 squares, and this one means it's in one of those 2 squares. Whoa! That means that these 2 squares form a 1-9 pair, and that means this square must be an 8. That locks an 8 into one of those squares, so this becomes an 8-9 pair now. These squares have got to be 6 and 7. The 8-9 pair sees this square and gives us a 6 now. Oh goodness me, this is quite stunning, isn't it? Now look, we've got 8 9s here and here. So looking down at this column 2, where do we put 8s and 9s? We know they must be in these 3 squares. Oh, this is brilliant. Look at this. This is brilliant. So now this square can't be an 8 anymore. Or it can't be a 9 because of that 9, but it can't be an 8 either, because if I put an 8 here, this diagonal needs to add up to 12, which means it would have to be 1, 3 and 8. Well, that's impossible. If I put an 8 here, we know the 3 is not going to be on the diagonal. So this square can only be a 3. And these other 2 squares are obviously an 8-9 pair. So we've now got 8s interacting. So there's an 8 in one of these 3 positions. Right, just let me have a stare at this for a second or two. So which clues... Which clues have I used? I've used this one. I've used this one. I haven't used this one as much as I might like to. This can't be a 9 because of the 9 here. So the 9 is in one of those. Yeah, that is useful. The 9 is in one of these 2 squares. And the 9 there is also in column 7 or column 9. So the 9 up here is in one of those 2 positions. So I haven't used this one fully. I have used this one. This one is interesting now. So there's a 3. Ah, yeah, that is interesting, because we now know that there can't be a 1 in either of those squares, because if there is, there would have to be an 8 in the other square, and the 8 is in the other position. So there are no 1s there, there are no 1s there. The 1s must be in those 2 squares. And now they marry up with column 1 and column 3 above, so the 1s must be up there. What is going on here? This is unbelievable. Okay, so do I have to use the 30? I can't use the 56 clue. That is ridiculous. That 56 clue must come to solve a sort of ambiguity at the end, I would think. So it's got to be the 37 clue. So I've got 14 already in the diagonal. Can we do it any better than that? Threes, look, these threes interact on this box. There can't be a 3 in the 22 lines. There is a 3 on this diagonal as well. So we've got a 2, we've got a 3, we've got an 8, we've got a 6. Oh. So let's just think about this. We've got 14 here. So that means that we need 23 from these 7 squares. That is a lot of squares to equal 23. And we know this one must have some significant value because it's part of a 22 diagonal. So the minimum value for this square would be 5. Just wondering whether we can tell anything about 5s. Not sure. But let's have a think about this. So, oh, my Alexa's just turned off.
I can't connect to your Wi-Fi network.
Good.
You can find setup instructions.
Sorry about Alexa interrupting the video. But let's have a think about this diagonal. So, you see, we've got 3s here. So this could be 2 and 4. In fact, let's put that in just for a second. That could be 2, 4. This could be 2, 3. Can't be 1 because of the ones there. We know there's a 3 on this diagonal. There could also be a 2 by the looks of it. So if we took the absolute minimum values, we would get 5, 10, 16, 22, 30. So this square can't be an 8. Because if it's an 8, it's going to break the 37 total. Wow. So the 8 is locked. Oh, this is amazing. So the 8's locked here. The 8's are locked here. Again, where do we put an 8 now? In column 8. It must be there. And we get another pair. So now 6 is in one of those 2 squares. Oh, and more important than that, 8 is not on this diagonal, the 22 diagonal. If 8 is not on the diagonal, we know that this is 9, 6, 7. And we know that this square can't be a 9. So this is a 6 or a 7. This is 9, 6 or 7. Okay, what can we do next? Got to be careful here because this could still be a 6, I think. And if this is a 6, all of these digits along here, well, one of them could increase by 1. So is there a way of us disambiguating this square somehow? This 6, look, there must be a 6 in one of those 2 squares. Yes, there is. That's brilliant. Now this 6 sees this box. And the 6 here, therefore, is in the vertical part of this box, and therefore it sees that square and makes it a 7. So this is a 6, 9 pair now, where it interacts with this. This is the most remarkable puzzle. This is quite stunning. So now, where do we put a 6 in column 8? Oh, sorry, row 8. You can't put it in any of those squares. It's got to be in one of those two positions. And we know that all of these are absolute minimum values. So that is presumably useful. Yes, it is useful, because now we've got 2, 3, 2, 3 there, so these two squares must be a 2, 3 pair, which means these two squares are a 1, 4 pair. And that places a 4 in one of those two positions, creating another 1, 4 pair. These two squares have got to be a 5, 8 pair by the looks of things. There must be a 4 in one of these two squares. A 4 in one of those two squares. I haven't used any now. Okay, I've used the 37 diagonal now. Still need to fix this 12 diagonal. I think I've used all the other diagonals though. Feel right. So let's have another look at this box. We need to fix these two squares. Now they can't be 3 and we've got a 3, so we know these two add up to 9. They can't be 3 and 6. They can't be 1 and 8. So they've got to be 4 and 5 or 2 and 7. But we have a 2, 3 there and a 2, 3 there. So actually we know that there must be a 2 in one of those squares. So that is a 2, 6 pair, which means the 7 can't be on the diagonal. The 7 must be in one of those squares. This must be a 4, 5 diagonal. This is mind-blowing. How on earth was this constructed? Look here, we've got 5s in the diagonal and 5s in the diagonal here. So the 5 is in one of these two squares, which we're getting used to that logic now, I think. 4s. So I think, have I now used all the diagonals completely? Apart from this doesn't equal 56 diagonal. So we should, I still don't think this is useful. There's just too many options along this diagonal. So we should be able to make more progress with standard Sudoku now, I think. This 7, yes, that locks a 7 into one of those squares, so that becomes a 4, 7 pair. That means these two squares must be a 5, 6 pair. Now we've got the 5 pattern here, so the 5 must be in one of those squares. Which means these are a 4, 7 pair. Now there's a 3, 7 pair above it. This is remarkable. Everything's resolving itself to a pair. Must be a 5 in one of those two squares. In fact, we know, looking at this row, we've not yet managed to place a 4, so this is a 4, 5 pair. Therefore, this is a 6, 7 pair. And it is, the whole grid is going to resolve itself down. Now, one of the very fascinating advanced techniques in Sudoku is the bug technique, which would actually, if you reach a situation in a classic Sudoku where every cell can only be a choice of 2 digits, which is I think where we're going here, the Sudoku is broken, it doesn't have a unique solution. But here, of course, that's not the case. Now, why isn't it the case? Well, it's not the case because of this 56 clue. This 56 clue is going to solve the puzzle for us. That is, look, that's what we've reached. We've reached a position where everything is a pair. Wow. And it's not everything is a pair with sort of 4 or 5 digits to go. It's everything is a pair with 72 digits to go. Now, let's look at this diagonal then. So this diagonal must not equal 56. Oh, well, this is cool because what we're going to be able to do is use the undo function here. So if we look along this line, well, first thing to note is that whichever, we can just pick a digit along this line and choose one of the options, and the whole thing will propagate through the whole grid. So I think this square is the most natural to choose because it's got the most extreme values. And in fact, we might be able to guess at what we think the answer is going to be, because 50 is 1, 2, 3, 4, 8, 7. So we need an average of 7 along this line. Actually, it could. I'm not sure. It could still be either way round. Let's try 9 first. So 9. If we put a 9 in here, what's going to happen? I think we're going to get the whole thing is going to unravel. I think. Let's see. 5, 6. We'll just go to the point where we've got the diagonal filled in, so we can see what it adds up to. Look at this. 9, 8. This 8, everything is seeing everything else. There's always another way to make progress. 9, 8, 8, 9. Okay, so where do we go now? What else did we fill in there? I've forgotten. 6s, we filled in a 6, yeah, 6, 7. That 7's going to see something, yeah, 7, 4. 4 should see something, it does. 4, 5, that sees the 5 and the 6. Now, what else? That 7 also sees the 8 down there, look. Now that 8 should see something, yes it does. 8, 9. That 7 sorts the 7 and the 1 out here. That's going to allow us to unwind the 1 and the 3. We're still not quite finished that diagonal yet. That's a 2, that's a 3. That's going to be a 4, that's going to be a 5. That's going to give us a 5, 6. That gives us a 6 on the diagonal. So we've only got one more digit left to do on the diagonal. 2, 4, 2. 3, 2. 3 sees the square. This is so funny. 1, 2, 2, 3. Okay, so what do we do now? This 1 must resolve that. 2, 3 must be resolved. Yeah, that's resolved like that. The 5 resolves the 1 over here. 3 and the 7 are resolved like that. The 8 and the 9 are resolved like that. 5, 6, 7. Ah, the 6 there, look, that's a 7. So this is a 6. 7 fixes the 7 and the 4. That gives us the final digit then. But we're nearly done, so we might as well just finish off. 5, 8, 7, 6. Now if I click, is this correct? I'm predicting that the software will say it is. Let's see. Yes, but it might not be. We have to check. So let's have a look at this diagonal. What does it add up to? 13, 23, 32, 41, 50. 56. Now this is the wrong answer. Obviously this must not equal 56. Right, so we have to do, let's see if my gaming mouse does perform now. I will click as fast as I can to get us back to the position we were in, where we just had 9 digits in the grid. That's where we were. And we're now going to find the correct solution by doing exactly the same thing again, but every single digit we just entered was wrong. So we need to unwind exactly what we just did and choose the other digit for the cells. And hopefully, if I do that properly, we will find the correct solution. 5, 4, that gives us the 4 and the 2. The 2 gives us the 2 and the 3. That gives us the 3 and the 2. That gives us a 3 and a 1. The 1 gives us a 1 and a 2, and a 2 and a 3. That leaves us a 3 and a 2 here. The 1 and the 4 can be fixed. And okay, now let's carry on. The 1 and the 5 we can do over here. That's probably going to unwind more stuff. 5, 6, 4. Yes, the 4 up in the top left, look, that fixes the 4 and the 5 there, which fixes the 5 and the 6 there. Bounds back into the 6 here. Something quite cathartic about doing this. The 8, 9 is resolvable. That 9 gives us a 9 and a 6 down there, look. And a 9, 8 here. 6 fixes a 6 and a 7. That fixes a 6 and a 7. 6 and a 5 we can do. 7 and a 4 we can do. That fixes the 4 and the 5 in the centre. The 8, 9 is fixed over here. 9, 8 here. 9, 8 here. 1, 3, 7. You can see the 1s and the 7s are now going to unwind nicely, which is what we'd expect. This must be a 4, this must be a 1, and that 7 there unwinds the rest of it. 7, 4, 4, 5, 5, 8. Now, check. Yes, this is the solution. Now let's see what we should have had on this diagonal. So that's 13, 21, 22, 30, 40. So had this been 40, we could have done it a different way. But I think that the reason that Mitchell's done it this way is he wanted us to get to that point where we just had those 9 digits in the center of every 3x3 box and everything else was a pair. That is a stunning Sudoku puzzle. I loved that. Thank you very much for sending it to us, Mitchell. And yeah, if you've got time to send us a few more puzzles, they would be most welcome. See you tomorrow on Cracking the Cryptic.